Hi, Dahlia Remler here again. We're now about to start the second half of the course on causal research. I'm really excited. Writing this part of the book was why I originally wanted to write the book, and why Greg Van Ryzin and I joined together to write it. So the second half of the course is really about getting evidence to answer questions like what works and how well does it work. If you have some program, treatment, intervention, independent variable, how can you determine its effect, or whether it has one, on an outcome, a dependent variable? Most of you are practitioners and you want to change the world, or at least some small corner of it. Maybe you want to increase high school graduation, improve health, reduce crime, make your organization more effective or more efficient. You need to figure out if your ideas of how to do that work, and if so, how well. It turns out that this is a lot harder to do than people often think. But don't worry, in the chapters that follow, you'll learn a lot more about how to get good evidence and about what evidence is credible. This is the area of research that is now commonly known as causal inference, making inferences about causal effects. This first chapter in the second half of the book, the Causation chapter, chapter 11, focuses a lot on theories. So you might wonder, why do so much theory in a course about research methods to gather evidence? The answer is that theories, and especially your ability to come up with them, are central to figuring out how to produce good evidence. And especially for practitioners, it will help you be a good consumer of causal research, of evidence that other people have produced. Sometimes that's in a formal research article or report. Sometimes it's just some analysis someone does, or maybe even some marketing person does to say, hey, this is great, it works. So this will help you figure out whether, in the words of a student of mine, whether the study really says what it says it says. More than 10 years ago, a student of mine came up with that. So that's what this course is about. And I really think it is. Someone did some study, some analysis, or so on. Should you believe its results? What is it telling you? So think about the example we have in the book, Family Dinners and Teenage Substance Abuse. This is a quote from, I think like 15 years ago. More actually, of a survey done every year, and they found that years of surveying teens have consistently shown that the more often they have dinner with their parents, the less likely they are to smoke, drink, and use drugs. The same organization has continued to do the surveys, and this has continued to be true. And you see, for example, here in marijuana use, that among teens who have dinner with their families only between 0 and 2 dinners per week, 27% of them report using marijuana, whereas among teens whose families have dinner 5 to 7 dinners per week, it's only 11%. And then they say later that the most effective thing we can do is parental engagement. No more effective example than frequent family dinners. So what you see is that they have jumped from this correlational or association empirical evidence, which is very good and very accurate. They have concluded that family dinners are effective, that they are responsible for changing the substance abuse or substance use by teens. So correlation, as you know, is an empirical relationship between two variables, so that if you change one variable, changes in one variable are associated with changes in others. People with more education tend to have higher incomes. Men are more likely to be Republicans. Sometimes people make a distinction between correlation, the thing you learned in statistics, which is relevant for quantitative variables. Association can also be categorical variables, including nominal categorical variables that direction. We're not going to emphasize that difference. We're pointing now to the fact that the evidence was correlation, but they made a causal conclusion, and they, in fact, had a proposal, family day, a day to eat dinner with your children. Okay, so they concluded causation, and basically they said if you could persuade parents to have more dinners with their children, so remember this variable, they're trying to sweep it up, more family dinners. If they do, it will propagate in the direction of the arrow, and drug use will go down. Remember, opposite direction. So more family dinners propagates this way. As a consequence, less drug use, or fewer family dinners, more drug use. So there are many alternative explanations for correlations. One of the first, and one to always remember, is the idea of reverse causation. If a teen does drugs, they want to avoid their parents, they don't go to the family dinners. But what if what we said was the independent variable, family dinners, is kind of actually the dependent variable? So now the arrow is going the other way. What does this say? It says, oh, when teens use more drugs, the arrow of causation goes in the other direction, and that results in fewer family dinners. If teens use less drugs, then you would get more family dinners. According to this theory, you can extort all the parents to have more family dinners, guilt trip them all you want, and it won't matter, because according to this theory, and it is theory so far, it's not the family dinners that drives drug use. No, it's correlated because it's the teen drug use that drives family dinners. So if this is the only reason for the correlation, you can push on this variable all you want, but there's no arrow coming out of it towards drug use. It won't matter. So a second alternative theory that could explain the correlation between the frequency of family dinners and teen substance abuse is a common cause theory. So the idea is something like family connectedness, which psychologists have studied and found to be an important aspect of family dynamics. If the family is very connected, then teens will enjoy time with adults, and they'll be more likely to want to have family dinners together, and they will be more likely to succeed. Same can also be true for adults. But also separately, if there's a lot of family connectedness, teens can have a sense of belonging to the family. They're not as upset. They don't have a sense of being as adrift, and they will be more likely to avoid drug use. So in the sort of jargon people use, it's not that A causes B is why A and B are correlated. Some other C, some common cause, causes A and it causes B separately. When there's only the common cause, this is also known as a spurious relationship. So here we see this in the diagram. Here we have the same family dinners, which we're thinking of as our independent variable, drug use, the dependent variable, but according to this theory, what's driving the correlation is family connectedness. More family connectedness, more frequent family dinners. More family connectedness, less drug use by teens. You can do it the other way. Less family connectedness, fewer family dinners, less family connectedness, more drug use. And so what you see then is that family dinners and drug use are correlated now. According to this dotted line, they're negatively correlated. They tend to be in opposite directions in the data. But you see this dotted line has no arrows. It's not causal, it's just correlation. Like you learned in statistics, correlations have no direction. The two variables are completely symmetric. You can even remember the formula for the correlation. X and Y were completely symmetric. That's why that dotted line has no arrows. And so, as with the reverse causation, if this common cause theory is the entire explanation for the correlation, which is the model that we've drawn, the causal diagram we've drawn, then you can push on family dinners all you want. Guilt trip the families, may have them have big efforts to get those family dinners. And nothing would happen to the teen drug use because there's no arrow going from family dinner to drug use. Another way of looking at this is the lack of comparability between the teens who have more family dinners and the teens who have fewer family dinners. Maybe their families are more connected, the ones with the more family dinners. Maybe it's just that those are the teens who are non-drug users. You should think about what other differences you can think of. Because the basic problem we have is that this is not an apples to apples comparison. And in the next chapter, when we look at observational studies that try and nonetheless estimate causal effects, when we look at, randomized experiments and natural cause experiments, this idea of a fair apples to apples comparison will be very important. We'll see that again and again. So now is a good time to pause the video. Think about, other differences. And we want you to get in the habit of thinking of these alternative theories whenever you hear about two variables being correlated or associated. See every time if you can think of as many alternative theories as possible that explain or predict that observed correlation or association. You want a theory that is, why do you have the evidence? We're not so interested in theories that contradict the evidence. We want theories that are consistent with the evidence, which is the correlation in this case. But that, critical thinking that contradict the supposed causation. Like, so, oh, look at those family dinners, they'll reduce drug use. That we're looking for theory that contradicts the idea if you change this supposed independent variable, what we're thinking of the independent variable, that as a result, they'll change. So basically, you're looking for theories where the arrows don't go from your independent variable to your dependent variable via any route. The two basic structures are causation and common cause. And if you get in the habit of thinking of these alternative theories, you'll be able to create better causal evidence, and you'll be able to interpret others' causal evidence, supposed causal evidence, to not erroneously conclude causation. You'll be able to accurately infer causation. And I want to stress, it's not that you say, oh, correlation, it's not causation, who cares about correlation? No, correlation is extremely important, valuable evidence. I don't want you to just dismiss it. It's very important evidence. But at the same time, you have to think about what are all the various reasons you could have that extremely valuable, important correlational evidence. be that family dinners really do cause drug use to decline, and also that family connectedness is a common cause of family dinners and drug use. That both are occurring. Now, why does that matter? You might say, okay, you thought family dinners reduce drug use, and it really does. So what's the problem? The problem is by how much? The magnitude of the estimate. And the problem is that people were kind of interpreting the magnitude of the correlation as the magnitude of the effect. Remember that publicity about the survey, they started out with their, hey, look what happens, look what a difference it makes family dinners, and say there's no more effective method. So in effect, they are looking at these differences and saying that they are all attributable to the family dinners. That's what it means when they say there's no more effective approach. So basically, they're looking at the 27% of teens in the families in the 0 to 2 dinner per week category, comparing it to the 11%, and basically saying, you see that 16 percentage point difference? That's the difference frequent family dinners make. Well, supposing we somehow manage to, guilt trip all the families and they rearrange their schedule and they didn't work and all the consequences, would we really observe a 16 percentage point lower use of marijuana? Would it decline as much as the table suggests if this is the reality? Yeah, there really is a causal effect, but there's also this common cause. That 16 percentage point decline, are we right to include that it's all from there? No, it's biased. That 16 percentage point difference there is a biased estimate, meaning it's too high. It's systematically different from the truth. It's systematically too large in magnitude. This kind of bias goes by a number of terms. The most common is confounding, also omitted variables bias, and in the book we talk about some other terms too. And this is, I think, one of the most important skills. So we're encouraging you to always think of these alternative theories, but often in reality, it's not just an alternative theory. There's a completely different explanation. But if you thought that this causal effect was plausible, it may well be there, but there's bias. So you also get bias when there's both causation and reverse causation. Family dinners cause drug use. Teen drug use causes family dinners. And again, you want to get at the magnitude. Using correlation to estimate the causal effect is biased. It's often called simultaneity bias, a term from economics originally. We will see that it is harder to deal with reverse causation than common causes, but especially when we get to chapter 15 and how it's possible to use panel data over time, there are some approaches. So now I want you to think of some other examples of correlations that seem to imply causation. For that one example, can you think of an alternative theory that explains or predicts the correlation but contradicts the implied causation? There are two basic forms of alternative theory, reverse causation and common cause. Maybe think of some examples where someone was extorting, this this will be so effective, you know, marriage, full-time college, whatever it is, and you are like, yeah, I don't think so. Maybe you can get a little more analytical and precise about why you don't think so. And again, this is a very important habit, and it's a first step to trying to improve the evidence. So now, just to sort of show the full range of complexity of causal pathways, I want to review some of the things that we had from Chapter 2 on theory and models. One of the first is a causal mechanism. How and why do family dinners reduce drug use, assuming they really do so? One mechanism is through the intervening variable or mediator of communication. More family dinners, more communication between parents and teens, more communication, less drug use. The communication helps the teens see problems from drug use, think about alternative theories, or perhaps not have the emotional problems that drive it. I want to emphasize this is true causation. It's not an alternative theory. It's not an alternative explanation for the correlation. It is causation. Also want to review moderators. And again, there really is a causal relationship, but the causal relationship is different. So it turns out when I went into the more recent evidence about family dinners and teen drug use and other substance abuse, alcohol, and so on, it turns out that the causal effect of family dinners on teen drug use was very much there for female teens, for teenage girls, but either much smaller or not there, not statistically significant in one study, for males, for not females. So reminding you about the moderator, this way of doing this shows that you see this relationship, how more family dinners, less drug use, fewer family dinners, more drug use. The size of that relationship is moderated by, influenced by the gender of the teen. The magnitude of that relationship is bigger for a female teen and smaller for a not female teen. So, like you knew, the real social world is very complicated. Real world associations combine many types of causal pathways. Causation with direct causation or mechanisms, intervening variables. Reverse causation. Common causes, simple common causes. There can be more complicated paths as well. Most phenomena of interest have many causal pathways. So here's what we see for family dinners and drug use. I'm sure you can think of even more. Wait, we're not quite ending, because I thought you guys might want to know something about the evidence of the effect of family dinners on teen drug use. And it turns out there's actually been a good amount of research on this since we finished the second edition, and we looked it up for the third edition, which is coming. And there are a number of studies, and basically what they boil down to is that there really is a causal effect of family dinners on teen substance abuse, to the best of people's ability to develop. And when they had a variety of approaches that accounted for common causes like family connectedness and for reverse causation using some of the longitudinal data over time I talked about, what they found is that the effect of family dinner on teen substance abuse was about a third of the magnitude of the effects in that study that we opened with from CASA. Now, there are some other differences, population differences, and so on. So it's not the case that we know that the omitted variables bias was 2/3, and the remaining 1/3 of the effect is the really causal one. But what we can be fairly sure about is both that there really is a causal effect, and that if you do not account for common causes and reverse causation, you will have a very substantially upwardly biased estimate. So hopefully now you can see that all these theories are actually really practical, and you're going to be able to put them into effect starting in the next chapter when we talk about control variables.